Alright. And now we can say, using proposition 1, 2, that the length of GH is equal in length to the length of GI. Okay? Let me pull this down a little bit. There's letter I right there. Okay? So GH equals length GI. Now, if we were to subtract the length of GD and GA from the length of GH and GI, then we would have AI equaling DH. And when we do this, we've now said that DP equals DH, and now DH equals AI. But that still doesn't give us point E. Now, how do we get point E? Well, we use proposition 1, 3. And I'm sure now you remember proposition 1, 3. Alright. We're going to take centermost part A, outermost part I, and we're going to strike yet one more little circle. And that's what's going to give us point E. And then we're going to draw a line from point D to point E. So we now have line DE. And now we can safely say that because DA equals DP, DP equals DH, DH equals AI, and now we can say AI equals AE, then we can say DA equals AE, which is exactly what we wanted to do. Now, Euclid says, I want you to construct an equilateral triangle. So what we're going to do is we're going to take our little compass here, and we're going to draw it from D to E. Now that means that the center of this circle will be D, the outermost edge will be E. And then we're going to do the same thing. We're going to make center E, outermost part D. And when those two lines intersect, we've got a point F. And using proposition 1, 1, that's right, Euclid's Book 1, Proposition 1, we now have an equilateral triangle, DEF. Alright, so now we're going to go back through one more time to make sure you understand what we did. By Proposition 1, 2, we proved that DA equals DH, and DH, of course, equals AI. That was Proposition 2. By Proposition 3, we proved that AI equals AE. And so therefore, using Propositions 2 and 3, these are from Book 1 of Euclid's Book 1, Propositions 2 and 3, we can now say that DA and AE are equal in length. And then by using Proposition 1, 1, we also said that DE, DF, and FE are equal. This is a whole equilateral triangle here due to Euclid's proposition number 1. Alright, but Euclid's not done with us yet. Oh no. He says to draw a line between point A and point F. And there's your line. Alright. Now comes the fun. We have now established that DA and DE are equal. We also established that DF and EF are equal. And of course, AF and AF are equal. That means, right here, and I'm going to show it to you. I'm going to turn the camera up now. Now, I know you can't see me just yet, but anyway, it means we have two triangles that are equal in size. DAF and EAF are two triangles that are exactly the same size. Now, if you remember from Proposition 1.8, if you have two triangles that are equal in size, then all their angles are going to be equal to one another. And because of that, we can now say that angle DAF is equal in size to angle EAF. That's by Proposition 1.8. And because of that, we now can say that line AF bisects the angle BAC. Okay? Because remember, angle BAC is just an extension of angle DAE, which we've already said was bisected by AF. So extending those two rays out is not going to make any difference. Alright, now to summarize all of this, I have a little chart here. AD equals AW because of Book 1, Proposition 2. AW equals AE because of Book 1, Proposition 3. DF equals EF because of Book 1, Proposition 1. And of course, AF equals AF, and that's just kind of an equality property that we found earlier on in the definitions. So now we can say the angle DAF equals EAF because of Book 1, Proposition 8, and therefore we have now said that line AF bisects angle BAC. Alright. I will talk about more in a future video, so stay tuned.